is the difference when I should use a array delete and when I should use a normal delete. So all these changes and small things we saw. And today we are going to slowly jump into reference counting and garbage collection. So I am going to use a mix of notes to document code, because my handwriting is really bad, and I think probably last few sessions it may have caused some problems to you. As we did last time, if you have any questions, keep posting those questions on the chat. I will read the question and I'll answer it. This way we won't disturb everyone, and again you will be able to hear me better. So what we are going to do is start with a simple example of what is called as a resource allocation is construction. So let me show you a simple code where I am defining a class X. Unfortunately, sticky notes are not a good way to, does not allow me to do any formatting. Let's see what else can we. Okay, let me try again. So I'm writing a class X, and guys, please put your phone things on mute so that you don't, mics on mute so that we don't disturb everybody. So we have class X, and let's say this, I am defining this class X. And it doesn't really do anything. Let's say it just has a constructor X and a destructor, and it doesn't do anything else. And then I declare it into another function, where I'm writing some function f1. And all I'm doing is declaring an object of X. Once the object is declared, I'm defining some if condition, something if a equal to 10, and then something happens, and then I close the function. Now when I execute this f2 function, if you see this example, what it typically does is it calls the constructor, and before it exits the scope, it calls the destructor. So during the initial versions of C++, C++ coders realize that this property is of amazing help, and they can use this of automatic destructor call to manage resources. They can use this property of automatic destructor calls to manage this resource. Consider this scenario where this class X is actually has a file pointer. So inside the X constructor, it is doing a fopen with some name. And inside the destructor, it is doing a fclose on that function pointer. Now, the moment I do that and I go to this kind of function where there is a f1 which is declaring a class object X, it will ensure that while the moment f1 exits, which may be for any reason, which may be because of a return call, which may be because it reaches the end of the function, or it may be because of an exception. The C++ compiler guarantees that any object created on stack, its destructor will get called. And this call to destructor will ensure that the function, this call to destructor ensures that this function closes the file. It guarantees that file is always closed. The moment it goes out of scope for F1, the file is guaranteed to be closed. You don't have to add any try catch, you don't have to code any extra function, because you have created this object on stack. The moment your F1 exits, the object is guaranteed to be deleted. Okay. Now this happens only if I'm doing it as a object created on stack. If I create it on heap like this, okay, the moment I create it on heap, there is no guarantee that this object will get deleted. Now this results in a whole lot of interesting confusions. Okay? The code can become messy. If I start if I keep creating objects on heap, and there is no guarantee when they will get deleted. So this called can be used in various ways. The way I showed you was guaranteeing that the file will get closed when the function exits. Okay? The exactly same thing happens in two C++ STL classes, and those are called auto pointer and pointer. For reasons we are not going to go into, auto pointer is deprecated, so do not use it. If you are using it in the past, convert it to unique pointer. It's important. I strongly suggest that you go and read the comparison of auto pointer versus unique pointer to understand why it is important to convert. Show you an extremely simple thing of how unique pointer is used. So unique pointer essentially adds inside, when you do a unique pointer and use a code like this, okay. So what it does, it creates a unique pointer, and unique pointer has its own in thing like this. Unique pointer. Remember, this is a class, okay? So this is a class. So the unique pointer class looks like this is a template. So it has a T star PT. So it just stores a pointer inside. And in the constructor, it just assigns PT equal to new X, something like this. So anytime you construct a unique pointer, the pointer is assigned a value. Anytime when the unique pointer gets destructed, it just calls delete of this pointer. Okay, so it just calls delete of this pointer. So it goes into the code similar to we saw previously. Now instead of assuming that your X is a unique pointer, The moment it goes out of scope, it will call the destructor of unique pointer, and that will delete this pointer. Okay, so the moment your function f is over, you are guaranteed that the memory allocated on heap is freed. Okay? You are guaranteed that memory allocated on heap is freed. Okay, guys, I am sorry I did not see your messages. I hope you are able to see the screen now, and you are also able to see the audio. Is that okay? Okay. So can you tell me what you missed? Then I'll just repeat that. Just post it on the chat window on what you missed or up to what point I was audible to you, and I'll repeat the portion after that. Just give me a minute. From the start of unique pointer. Okay, so let me repeat that. Okay, Swapnil, auto pointer is deprecated in C++11. I'm not 100% sure, but it is definitely deprecated in C++14. I think unique pointer also was introduced in C++11, so I assume that auto pointer was also deprecated in C++11. But there is still a lot of example code you will find on net which uses auto pointer, and it's a bad idea to use auto pointer in your production code now. So let me go back to unique pointer. And so remember, the unique pointer is a class. It's a template class. And when you create a new unique pointer, a unique pointer internally has a simple pointer as a member variable, as you can see here. As you can see here, unique pointer has a simple pointer as its member variable, and in the constructor, the new x is assigned to that pointer. And in the destructor, this pointer is deleted. So the unique pointer is created on stack inside a function when you want to ensure that the allocated memory is freed at the end of the function or at the end of the scope. Because the moment unique pointer is deleted, it goes, or the moment unique pointer goes out of scope, it deletes the memory. So I was showing you something like this, where instead of x, we have a unique pointer x equal to new x. When this unique pointer goes out of scope, there is a hidden call at the end of the function, which essentially calls the destructor of this unique pointer. So it calls the destructor of pointer x, and inside this destructor, the memory is freed. So that guarantees that you will never get a memory leak from this function. Irrespective of what happens, at the end of function f1, the memory allocated on the heap is deleted. Guaranteed. Okay. So as you can see, unique pointer is one example of what is called as resource acquisition is construction. Okay, so inside the constructor, you are acquiring a resource. One of the, in unique pointer, that resource is memory. So you are acquiring memory. The original class X that I showed you, the resource was a file pointer. So you are opening a file and acquiring a file pointer. Inside the destructor, you release the resource, which means if it is a memory, you delete the memory or free the memory. If it is a file pointer, you close the file pointer. If it is a database connection, you close the database connection. This is a very common pattern of RAIC is a very common pattern of managing the resources in face of errors. Even if the error occurs, even if the F1 throws an exception, the unique pointer is guaranteed to be freed. Unfortunately, there is nothing equivalent in Java. And why it doesn't work in Java, we'll see, because that is the implication of using garbage collector. However, there is something similar to unique pointer or the concept of RAIC in .NET with the iDisposable interface. So when we come to .NET and garbage collection, we can talk about iDisposable interface. Now, there are few peculiarities with unique pointer. And one of the peculiarities unique pointer is when I take a unique pointer P1 and assign it to new X, then I have another unique pointer and I have P2, and when I say P2 equal to P1, interesting thing happens that ownership of the pointer is transferred from P1 to P2. Okay. So essentially, operator equal to of unique pointer does something like this. This dot pt equal to other dot pt. And at the end of so the ownership is transferred from P1 to P2. And if P2 goes out of scope, that is the time the memory is deleted. Okay. And this can create surprises in your C++ code. Consider the scenario where you have a code which is like this, where you have a function f1, and inside that you have created p1. Inside that you have a if condition, and inside the if condition you have a p2 equal to p1. When you have this kind of code, when this if condition goes out of scope, the memory is deleted. Memory from P1 to P2. Okay. The moment this if condition goes out of scope, P2 will get deleted. Can others hear me? Can you hear me? Okay, so let me repeat again. Suppose you have function f1, and inside that you initialized a unique pointer p1 with some value, maybe equal to new x. Then you have a if condition, and inside that if condition you initialized another unique pointer p2, and you initialized with the value of p1. The moment that happens, the ownership of memory that you allocated here is transferred from P1 to P2. And when this P2 goes out of scope in this if condition, this memory is freed. Okay, so be extremely careful when you assign a unique pointer from one unique pointer to another unique pointer. Okay. operator equal to is private. Yes, but when you create a new pointer, unique pointer, you can create it from another pointer. And I think even in operator, uh, in unique pointer, I think operator equal to is not private. I think we can do a direct assignment, but I'm not 100% sure to share. I will have to check. What I definitely know is if you have a unique pointer p1 and unique pointer p2, I'm not sure if you can do p2 equal to p1 as equal to operator, but you can definitely do at the initialization itself. If you define p2 equal to p1, then it's a copy constructor, as Ramakant has said, and copy constructor is public. So you can move values from one unique pointer to another, but that changes the ownership. So be careful in using unique pointers. No, copy constructor is not private. You can assign one unique pointer, or you can create a unique pointer from another unique pointer. And I'll give you explanation of why unique pointer copy constructor is not private. Consider the scenario where you want to return unique pointer out of my function, out of some function. So let's say I have a function, I have a unique pointer x, and I'm returning that from function f1. And I created a unique pointer x p equal to new x, and inside this function I'm doing the return p. When I do this return p, remember this is a function on stack. This is an object created on stack. This object is created on stack. When I do a return p, this stack object will get destroyed. So it is important to create a new unique pointer outside of this p object. And that requires creation of a temporary unique pointer object and copying that unique pointer to another function. So then I will be able to do something like a unique pointer p2 equal to f1. This kind of code requires transferring the ownership from one unique pointer to another. And this kind of code is used pretty regularly. So that is why I'm confident that copy constructor cannot be private. Okay. Tushar, does that answer your question? That brings me to another scenario where you have to be very careful about is never add a unique pointer into a collection. Never add a unique pointer into a collection. Okay? So for example, never create a vector of unique pointers. This usually bombs. Okay? Why? Let's say you created this vector and now you are doing a for loop on this vector. Okay, I'm not writing the full for loop, but let's say x equal to begin vp dot begin, something like that. Maybe it's too horrible to write it little. For x equal to vp dot begin, then x is not equal to vp dot end, something like that. Okay. And now you have a unique pointer and you are equal to star x. Okay. So I'm back. Uh, so Abhinav, I saw your message, but I think I missed one message in between. The unique pointer guarantees that single unique pointer container has ownership of the head pointer. That is absolutely correct. That is exactly why when you assign a unique pointer to another unique pointer, the ownership is transferred. But there was some message about unique pointer deleting the copy constructor and equal to operator. I'm not sure about that. I need to check. So far, I was under impression that unique pointers can be copied. Auto pointers definitely could be copied, and yes, Mangesh, maybe I have not checked it, so maybe I'm wrong. I will check again. This was definitely the case with auto pointer when the ownership was transferred, and that is one of the reason why auto pointers were deprecated, and the memory constructor unique pointer was added. Okay. However, at that time there is something called as a move semantic, where the unique pointer can be returned outside without an intermediate copy. And I think that was not there in the original C++11 version, and probably added in C++14 version. In both cases, I'm not 100% sure on this, and I need to check. It was originally not there. So std move requires ownership transfer. Since std move was originally not there, you needed a equal to operator and a copy constructor. So guys, both Mangesh and Abhinav, you have successfully proven me wrong. Can we go to next now? Okay, so let's go to shared pointer. We saw the scenario where the problem was about resource acquisition is construction, and when things go out of scope, the pointer gets deleted. Now, as Mangesh and Abhinav has proven, unique pointer cannot be copied, so you cannot create a collection of unique pointers. It is not possible to create a vector of unique pointers. But then, if I still want to add pointers into vectors or inside the collection, and I don't want to take the responsibility of deleting them, what do I do? So that's where the shared pointer comes into picture. And shared pointers adds the concept of reference counting into this idea. So the shared pointer essentially has two member variables instead of one member variable like auto pointer or unique pointer. When I create a shared pointer t, it has a t star pointer and it has a int star ref count. Now, similar to unique pointer, when you create a shared pointer and assign an object to it, the pointer is assigned to pt, and first time when a reference shared pointer is created, it also allocates an integer for reference count. So ref count equal to new int. Then this ref count is set to 1. Okay. Any confusion so far? When I go to next, when I look at shared pointer p1 equal to p2, the pointers are copied. So essentially it translates to p1 pt equal to p2 pt. Right? However, the reference count is first assigned, reference pointer is assigned as it is, so p ref count equal to p2 ref count, so that the same reference count variable is shared between all shared pointers, and the reference count is incremented by 1. So you have the same memory location shared between p1 and p2, and now both have a reference count of 2. When this shared pointer goes out of scope, when say p1 goes out of scope, inside the destructor, it first reduces the reference count. So reference count goes from 2 to 1. Okay. And after decrement, if the reference count goes to 0, then the pointer is deleted. Okay. Now you can safely create a vector of shared pointers, use it in for loops. When I use it in for loop, the reference count will be incremented by 1. And when the entire vector is deleted, all the pointers will be freed. Okay. Is that clear? Any questions so far? Any questions on the memory part? Shall I go to next on shared pointers, because there are a lot of things we need to cover after this. Okay. So the best way is to use shared pointer, but what happens if there is a circular dependency between the shared pointers? So C++ gave you a good advantage that if you use shared pointers everywhere and unique pointers everywhere, you don't have to call delete. So it gives you a tremendous advantage that you just have to do a new and delete will be called automatically. But consider the scenario where I have a class X and it has a shared pointer of Y, and I have a class Y which has a shared pointer of X. If I create an instance of Y such that it is referring to the instance of X, and the same instance is referring to instance of Y, then I have created a circular dependency. X is referring to Y, so the reference count will remain 1, and y is referring to x, so the x referent count will also remain 1. In such cases, both the objects will never get deleted. And it's very difficult. Now, this is a simple circular dependency where x depends on y and y depends on x. But what if there is a x depending on y depending on z depending on x, again kind of circular dependency. It is very difficult to detect these kind of cycles in the code and ensure that all shared pointers are deleted. So a C++ coder still have to be careful about ensuring that the accidental cycles are not created using the shared pointer. This is exactly where the garbage collection comes into picture. When languages like Java and .NET were designed, the language designers were looked at the reference counting pointers, but they knew that reference counting will not be enough, because the moment you have cycles in the objects, it is not possible to fix those cycles just by using reference counting. So we looked at a lot of memory problems, and majority of the memory problems comes from two decisions, and that is the designer decision that what is the lifetime of the object. If I delete the object too early and there are still some other objects referring to it, you have a problem. If you delete them too late or don't delete at all, then also you have a problem because you are consuming extra memory. And the question as to when exactly I should delete the object becomes more complicated as you start collecting collection of objects. Those objects start referring to other objects, and then it starts becoming a mess as to what point an object should get deleted. So the languages like Java and .NET wanted to ensure that the developer is freed from this decision. He just have to decide when to create an object, and the system will automatically decide when to delete it. If it is properly done, then it reduces a burden from developer in trying to decide the life cycle of the object. But remember, GC just addresses one type of resource, that is a memory. But if you are managing other resources like file, database connections, cursors, you still have to resort to try catch or the constructor resource acquisition is construction kind of idioms to manage those resources. So what languages like of designers of Java and .NET wanted to achieve was I should be able to create an object by just doing a new a. Remember, now there is no pointer notation because in C# and .NET, every object is essentially created in on heap. You cannot create objects on stack. Okay? In C++, things are more complicated because you have a way of creating object on stack. You also have a way of creating object on heap. When you are in Java or .NET, basic data types get created on stack. Any user-defined classes always get created on heap, and that is they get created through garbage collector. So you will always see a new a kind of objects. So is this really a pointer? Turns out that it's not. It's a it's a hybrid between an object and a pointer. So typically it is called as a handle. So conceptually you can think, and we'll come to it why it is important later. Conceptually you can think that whenever you create a class in C++, it actually creates two classes. Okay. This is conceptually, you will not find an implementation equivalence. So when you are in C++ or Java or .NET, and if I define a class A with some data inside that, int A, int B, like this. Okay. What compiler does, it creates another class. I'll, I'll call it handle A along with this class A, and inside this handle A, it has a pointer to A. So it contains a star. And when you see an object A here, it is actually a handle. It is not a class object. Okay. So think of it is, it automatically creates a shared pointer kind of object, and it keeps track of this shared pointer kind of object in compiler. So which means when you access a member variable of an object, when you do a dot b, it actually goes through two steps, a dot pa and then b. So there's a level of indirection required when you are accessing objects in Java and .NET. Does it impact the performance? Very, very, very minutely. Usually you will not even be aware of it, but it does give a significant benefit of memory compaction when that happens. Okay, we'll come to memory compaction later. Uh, we are nearing to 7 o'clock, so I'm going to cover really basic things about garbage collector. We already saw why reference counting is not enough. So I'm going to go into a very simple step of what happens in a what is called as a tracing garbage collector. Okay. There is an optimization of tracing garbage collector, and that is called generational garbage collector. We will not go into generational garbage collector today. That is a big topic. However, what I will do is, end of the session, I will give you a few pointers on where you can find more information about generational garbage collector. So our objective, if the simple reference counting is not enough, then somehow we have to trace all the allocated objects in the system and then find out which objects are not referred by anybody else, and then remove those. So tracing garbage collector uses a concept or algorithm called mark and sweep to detect which objects are not referred. Okay. So to start with, it goes through all the allocated objects in the system. Now, obviously the garbage collector first, it has to keep two lists. Again, the list of allocated objects and a free list. Okay. So what mark and sweep does, it goes through all the allocated object list. Okay. And what we are looking at is a very dumb implementation of this algorithm. There are many optimizations on top of this, but it will give you idea of what happens inside a garbage collector. So it gives two allocated lists. Then it sets a flag on all those allocated objects to say that this object is unvisited. Okay. Then it starts with all the static variables in the system, which are essentially global objects, and marks them that these somebody is referring to this object. So it adds a mark. So first object, all static objects, they are ticked. Then there may be other objects in the allocated list. So it goes through first all static objects, marks them. Now, if the static class A has some other object inside, maybe B, and this B object is here, then it marks those as well. Okay. Then it marks, then it goes to stack frames and then checks which object are on stack and if those objects are referring to some other object. So by checking this reference tree, all those objects are marked. Okay. By using traversing the stack, taking all objects on the stack and taking all the objects, stack objects are referring to, as well as all global objects or the static objects in Java, they are marked. Once the mark phase is done, then the GC again goes through all the allocated objects, whichever objects that are marked, that are referred by somebody. So it checks those and takes care that, okay, I don't have to delete those. Whichever objects which are not marked, they are moved into the free list. This is called as a sweep phase. So first phase is mark. All the objects which are referring to somebody, they are marked. Objects which nobody are referring to, they are treated as objects to be deleted and they are moved to free list. Now consider our scenario of X referring to Y and Y is referring to X. Okay. What happens in the mark phase is you are starting from a static object and you are also looking at all the objects on stack. If none of those objects are referring to X or referring to Y, then X will not get marked, Y also will not get marked. They may be referring to each other, but in the mark and sweep space, they are not marked. In that case, both will get moved to free list, even though their reference count is 1. Okay. However, if some static object is referring to X and X is referring to Y, both will get marked and will remain in the allocation list. Okay. This is the because you are tracing objects with some starting point like the static variables or the variables on stack, and then tracing the objects by like a graph traversal. Essentially, it's a graph traversal. This garbage collector is called tracing garbage collector. But imagine that you are allocated 100,000 strings and you are trying to see which strings are still used, which are not used, and you are trying to run this kind of garbage collector at some periodic interval. The moment you start the garbage collector, all other threads have to wait. A naive garbage collector implementation requires that all threads has to wait. And then you have to go through maybe 100,000 objects in the garbage collector. If this is the scenario, then you have a whole lot of overhead. So it may end up that your garbage collection is taking more execution and CPU time than your actual program. Obviously, that will not be acceptable. That is why there is a concept added to tracing garbage collector called generational garbage collector. So as I said, we'll not go into generational garbage collector, but tracing garbage collector, there are a lot of performance optimizations added so that the overhead of garbage collection is minimum. But for now, imagine that you are using a mark and sweep garbage collector and you are running trace on that, and that trace has identified free list. Those objects are added to free list, and you keep doing this repeatedly. Eventually, it starts happening that your allocated memory has lots of gaps. So this may be allocated, this may be freed, then again allocated, then again freed, then again allocated, and again freed. Okay. All these holes means that when you iterate over a vector or iterate over a collection or try to use already allocated memory, it will start increasing your page faults and it will start reducing your performance. Maybe actually you need only 5 MB, but the OS starts thinking that you need 100 MB because there are a lot of free pages or free areas in the free list. So is there a way to merge all those free areas and move this allocation object from here to here to here, so that there is some amount of compaction happens and then your memory looks like this. So these are allocated and then all the freeze areas are moved at the bottom. Is there a way to do that? Well, actually, yes. So that is why in garbage collection there are really three phases. First phase does a mark, second phase does a sweep, and third phase does a compaction. Okay. And what happens in compaction phase is, remember we saw this handle kind of concept and this is a pointer. Now, as a user program, this pointer is invisible, right? For an individual application, this pointer is not visible. So during compaction phase, so let's go here. So I have an handle of A and it has a some pointer to A. Originally, this pointer was pointing to a location here. During the compaction phase, the garbage collector moved this memory location to here. All it has to do is change the handle pointer from the original location to new location. The moment garbage collection is over and my normal program execution is start, the program will start referring to memory, which is now here. Okay. Program is not even aware that the object is moved inside memory. Okay. This is how garbage collection can improve performance. By doing compaction and by putting the frequently used memory next to each other, it can reduce page faults and improve the performance of the application. Compaction phase is very important in improving the performance of the application. Remember, we talked about how C++ vector reduces improves the performance by putting next object immediately inside the same virtual page. Initially, that was not possible in C or in Java or in .NET because Java list looked like this. It is list of handles. So HA like this, and each handle is pointing to a different memory location in memory. Because these pointers can get allocated at different times, a naive implementation will increase the page faults of vector compared to C++ code. But because the compaction phase happens and the compaction takes care of putting these objects next to each other in RAM, that is why the data collection or the collection object performance improves over time in case of Java, but that facility is not available in C++. In C++, when I create a vector of shared pointers, the memory can get fragmented and accessing a vector of shared pointers may actually reduce the performance compared to vector of raw objects. The same scenario will not happen in Java because after Java or .NET periodically compacts the memory, the chances that objects inside the vector are next to each other in memory increase and the performance of collections improve in Java in uh, after garbage collection compaction phase. Ramakant, if say a language like C#, if I pin the memory, will it affect the compaction phase? To some extent, yes. It depends on which objects you pinned. Okay, the moment you say pin object, basically says don't change its memory location. But so generally, I will say avoid doing it unless you have a very very specific performance, low level reason where you want to ensure that the object is not moved in memory. In general, avoid tinkering with garbage collection. Only if you know the performance, if you do a profiling and then you realize that garbage collection is actually causing the problem, only then do it, and do it very, very carefully. The moment you start tinkering with garbage collection, you are changing the basic assumptions of the language. And you don't know how the overall performance will get impacted by those changes. Sometimes a small innocuous change in garbage collection can suddenly reduce your program's performance by 20%. Yes, majority of the languages trigger the GC, and because it manually triggers the GC, it's sometimes useful because, okay, so how do I put it? Consider the scenario that you expect garbage collection to happen automatically, but for some reason it is not getting triggered and your memory keeps on increasing. If you identify that, you can add a call to garbage collector to forcefully collect a memory at certain point. But if you do it too frequently, it can adversely affect the performance of your program. So you can manually trigger the GC, but generally, again, be very careful when you're trying to do that. Think I have covered majority of the issues. Uh, just let me put a few interesting links that you can copy. Okay, Ramankat, I'll answer your question. Just let me put those useful links to you first, and then I'll come to your question. There is one part that I missed in garbage collection, and that is what exactly happens in finalize. Okay. So this link from Microsoft explains what happens in .NET garbage collection, and it goes through lots of details. If you go through this document, all your doubts about .NET garbage collection will get cleared. This is a good example of a very basic mark and sweep garbage collection, and how the mark phase happens and how the sweep phase happens. It is explained with very nice diagrams. So it useful to understand the garbage collection. The Microsoft link that I posted also has a very nice explanation of generational garbage collection. This Wikipedia link of tracing garbage collection goes through all the details of mark and sweep and why that is sufficient, and why generational garbage collection is required, and how it improves the overall performance. Okay. So one thing we missed in garbage collection is what exactly happens in destructor. So in C++, there is a destructor, and because C++ guarantees calling of destruction a destructor at a certain point, like the program goes out of scope, or when you explicitly call the delete, there is a way to control the lifetime of the object. While Java and .NET allows you to define a destructor, destructor when this finalize will be called. So it may happen that you create an object in some function. You may create an object in some function f1. However, garbage collector is not invoked at this point, and a.finalize will not get called. Okay, so a.finalize gets called whenever the garbage collection is triggered. So Ramakant, your question on destructor of deleted objects are triggered by explicitly calling GC. Yes, it happens, but only when you trigger all the generations garbage collector. So typically there is generation 0, generation 1 and generation 2. So you have to trigger the garbage collection of generation 2, which essentially does the generation 0 and generation 1 garbage collection as well. That only guarantees that all the unreferenced objects are garbage collected and their finalized functions are called. Okay. Flip side is it is going to go through the full garbage collection cycle. So just to trigger the finalize call of some variable called triggering a GC is a big overhead. However, .NET gives you one benefit, and it defines an interface called iDisposable. So iDisposable is .NET's way of creating resource allocation as construction. So you can use iDisposable interface, something like using some object which implements iDisposable. When you do this and when you define a scope, at the end of this scope, it ensures that some object dot dispose function gets called. So if you are using .NET, then I'll suggest that you use this iDisposable interface. In my typical .NET design, I used iDisposable a lot and always used using keyword to tie the object lifetime to the scope of the code, so that anytime I go out of scope, maybe because of exception or anything, the dispose function gets called, and inside the dispose function you can close the files, close the cursor, delete the database connection, or whatever you want to do. Unfortunately, there is no equivalent of iDisposable in Java. You can do the same thing in Python using the context managers. Any questions so far? Is there any connection between delete operator and destructor? Okay, Swapnil, you mean C++ delete operator and destructor? C++ delete operator just frees the memory. It does not call the destructor. If you override the delete operator, it just frees the memory. It does not call the destructor. But when you call keyword delete and call it on a pointer, this call essentially translates into call the destructor, like pointer, call the destructor, and then it calls the delete of this pointer. So that is the free the memory. So essentially a simple delete call. Okay, let me restructure it a little. So the delete ptr call translates into first call the destructor and then call the operator delete function. Okay, so the operator delete is expected to free the memory. Does that answer your question? Swapnil, I hope that answers your question. Okay. Ramakant, what was that in Python? Python, it is called context managers, and context managers are used with a keyword with keyword. So there is a keyword called with, which is equivalent to using in .NET. So context managers are used with keyword. That with is a keyword that you use with context managers. Now there was some question about shared pointer. How to pass shared pointer to fiction, whether by value or by reference or const pointer, or we pass the pointer held by shared pointer as const to a function. How the first restrict. Sapnil, I'll come to your question again. Mangesh, how to pass shared pointer to functions, whether by value or by reference? You can pass by value, no problem. When you pass it by value, it increases the reference count of by 1, and at end of the function, it decreases the reference count by 1. So there is no problem in passing the shared pointers by value. Can you pass them by reference? Yes, you can, but preferably pass them as const reference. That is what I prefer. Okay. But the moment you pass the reference as shared pointer as a const reference, you can call const functions on that. Should we pass the pointer held by shared pointer as a const ref to the function? With new C++, never do that. If you are using shared pointers, use everything as shared pointer. If you mix the shared pointer and raw pointer, weird kind of things happen. For example, that you have a function f, and instead of passing shared pointer, you passed a pointer to it. Okay. Passing it as const pointer may be okay, but passing it as a normal pointer, somebody calls delete on it, weird kind of thing happen. So avoid doing that. In fact, if you are using C++ 14 and C++ 11, always work on shared pointers and unique pointers. Especially all your function signatures, work on shared pointer and unique pointer, and don't work on raw pointers. A lot of your headaches will be reduced. Use the raw pointer only if you are calling some old library which is working on pointers. All new code, work on shared pointer and unique pointer. Because you're defining so many shared pointers and defining those templates become messy. The C++ 11 and 14 added a keyword called auto. Use that, and compiler automatically determines the correct pointer. Swapnil, I did not understand your question. How, as we know, destructor is called after object scope end. Right then, how the first destructor gets called? What do you mean by first destructor? Did not understand your question. Or maybe you can email me and we can have a separate discussion on this. Okay. So before we conclude, I have one request for everyone. Last two sessions, we asked for feedback on how the session went and what else you want me to cover in the sessions. But frankly, I have received feedback from only one or two people. So it will be good if you can drop a mail to me. If you don't want to give the feedback publicly, that is fine. If you want to give the feedback publicly, please post it on LinkedIn. That is also fine. Ajay keeps you reminding about uh, giving the feedback, and he will write a mail to you again. You can just reply to that mail and give me and Ajay feedback. The mail also has a link to a LinkedIn post. You can post the messages on that for feedback. Okay, so thank you very much, Sampnil. Please write to me later. We'll have a separate discussion and I'll clear your doubt.
Hey, hi.